Hello makers, I'm Voldy, and today we are going to create some 3D printed RGB display elements and then build an internet connected weather forecast clock with it. Let's get started.
A few months ago, I bought a Creality Ender 3 Pro 3D printer, and after going through the mandatory print everything from Thingiverse phase, I wanted to use the printer for the original purpose of purchase, my custom projects. For that, I had to learn CAD. I think that the best way to learn anything is to set a goal, in this case a project, work towards it and learn new skills along the way. So I got an idea. Why not make an internet-connected weather forecast clock? For that I will need my favorite microcontroller, ESP8266, an acceptable looking housing for the clock and, of course, custom display elements. When it comes to, for example, displaying numbers, you have the option of using 7-segment display, which does the job really well in many cases, but it's limited in many ways and requires minimum 3 digital I/O pins and a specialized hardware. Or you can use alphanumeric displays. Those are small, or if you want to use bigger variants, a bit more expensive, and they still require several I/O pins. But did you know that if you have a 3D printer and a few centimeters of cheap addressable LED strips, you can make a virtually infinitely long daisy chain custom display, which only uses one I/O pin, and you can set the color of different segments separately, creating very cool animations, or use the color to display additional information. For example, you can gradually change the color from green to red, indicating the nature of the value. I know that there are good apps out there, but I still think that the initial planning is best done with paper and pencil. After planning the mockup for the weather display element, in which I had a lot of help from my little makers, I had to figure out the parameters of the display segments. The plan I came up with is a housing for the LED strip with a closable back and a light diffuser layer on the front. One of the biggest challenges was figuring out the exact material, shape and thickness of the light diffuser layer and its distance from the light source. I tried different shapes of clear filament, but at the end a thin layer of white filament with the exact shape of what we want to display worked the best for the purpose. Finally, after many hours of experimentation, trial and error, I have the final form, so the mass production can begin. Every separate part of the housing had to be printed separately and then assembled. When that was done, I went ahead with soldering and testing. I wanted to be able to clip the displays together, but since I'm not very experienced in 3D modeling, it did not work out well, so I had to use some isolation tape to hold them together properly. Display elements had to be soldered together. I used shrink tubes to prevent shorts. The weather display element is a good example of how any custom display can be easily made with this technology. So here's a demo of chain segments. Unfortunately, the video made with my phone doesn't do justice to how good this looks in real life. To complete the project, we will need a housing for the weather forecast clock. For this, I designed a simple wall-mountable box in FreeCAD. The volume of my 3D printer almost turned out to be too small for this. D1 Mini Pro with ESP8266 had to be connected to the whole thing, which I did with some connectors in case I need to disassemble it. At this point I had everything to finish the clock itself. First assemble the display segments. Then secure them in the housing with double-sided tape. After that was done, I hot glued the buttons in place and added a DC plug to power the whole thing. As an afterthought, I added an external temperature sensor to measure the in-room temperature and display it on the clock. I wrote and tested the firmware software in modules. First, I wrote the part which handles the display. On this picture, you can see how the LED strips are chained together. After this, you can address them as a single array in the code, and they only use one I/O pin. Writing the rest of the firmware was also really fun. I mostly used free APIs to fetch the user's external IP address, location based on that IP address, and weather forecast based on the location. At this point, I still did not know what will I use to cover the front of the clock, so I started to experiment with different materials. First, I tried to print a thin layer of patterns with clear filaments, but they did not work as expected. Then I started looking around in the office and found out that the dark but still see-through cover of the document holder does an amazing job of hiding the components, but still letting through all the light. Fantastic. This is what I need. At this point, all I needed was to design, print and add a few elements to the housing which will hold the front cover in place. So there it is, done. When you turn the clock on for the first time, it will create an access point so you can connect to it and enter Wi-Fi credentials. After this, it will automatically connect to it and set itself up. It can be restarted with the top button on its side, and if the other button is pressed while it's booting, it will enter the setup mode again, so you can change the Wi-Fi setup. All the 3D models and the source code can be found in the description below. I really hope you liked the project. If you did, please like, share and subscribe. See you next time.